Okay, so we're going to talk about the second section in our chapter about transformations. And this section has to deal with translations and reflections. Translations and reflections are just another type of transformation. So we're going to define and perform some translations and rotations, illustrates translations and rotations, and we're going to illustrate them as compositions of reflections, and then we're going to define the identity transformation. Okay, so anytime you perform two or more transformations on a geometric figure, you're performing a composition of transformations. So anytime you transform a figure two times or more, it's called a composition. So think of like a piece of music, a composition. It's pieces put together. So we're doing a transformation and then another transformation and another transformation, and it's composing our final piece, right? So let's look at the definition of translation. Okay, I already told you that translation is a transformation and it's a composition. Okay, so it's a composition of two reflections. Okay, so it's two reflections. That's what a translation is. And these two reflections just happen to be reflected on lines that are parallel lines. So you're going to reflect the pre-image across a line of reflection, and then you're going to reflect it again on another line of reflection, and that second line of reflection is parallel to the first line. Okay, so in the end, what you look like, it looks like you just took the pre-image and you did a slide to its new position. So a translation is sometimes thought as the sliding movement of the plane. Okay, so pre-image, here's our line of reflection, and we're going to reflect it. So this is where the word composition comes in, because we're going to do another transformation. We're going to do another reflection on this image that we have, and it's now going to become our new pre-image, and we're going to reflect it across this line of reflection. Notice that this line of reflection is parallel to our first line of reflection. That meets the conditions in order for it to be what we want. And so we reflect it again, and here is our new image. Notice how it looks like we just took this image and slid it over. There we go. All right, so again, we have this pre-image, A, B, C, D. We're going to reflect it across line 1, reflect it again, line 2, which is parallel to line 1, and we get our new image, A prime, B prime, C prime, and D prime. Okay, so now let's talk about the word rotation. So a rotation is a composition of two reflections, except for this time, our composition of two reflections, the lines aren't going to be parallel. The lines are going to intersect. Okay, so what that looks like. So we've got two lines of reflection. Here's one, and here's the other. Notice that they are not parallel. These lines intersect each other right here at X. So the first thing we're going to do is we're going to take this image, Hij, we're going to reflect it across the first line and get I prime, J prime, and H prime. And then we're going to take I prime, J prime, H prime and reflect it across the second line of reflection. And we get double H prime, double I prime, and double J prime. So notice we just took this pre-image and we rotated it clockwise to its new image. Okay, so that X where the two lines of reflection intersect is called the center of the rotation, right? That's where you are kind of grabbing it from and then you're moving it from that spot. Okay, and I did say that this direction of this rotation is clockwise. So we can calculate something called the magnitude of rotation. It's going to be twice the measure of the acute or right angle between the lines of reflection. So this angle right here, okay, that's the angle between the lines of reflection, this angle right here. Okay, and the magnitude of our rotation is twice that amount. Okay, so if they give us the actual magnitude of rotation, they say, well, your magnitude of the rotation is 95, which means that the angle between the lines is going to be half of 95. So it's going to be 47.5. There we go. All right. So last thing we want to talk about is something called the identity transformation. The identity transformation just maps each point of a geometric figure onto itself. So A and A prime are right on top of each other. B and B prime are right on top of each other. So it's basically a transformation that does not move the pre-image. The image and the pre-image are exactly in the same spot. All right, that's all we have. It's your turn. You're going to do 12.2, 2 through 6 evens.